into what's called the fundamental theorem of algebra. What this theorem states is that if we've got an nth degree polynomial, we always have n roots, provided, of course, that we count the multiple roots accordingly. Okay. Let's have a look at another very important statement here, which is the conjugate root theorem. This theorem states that for any nth degree polynomial, provided that all the coefficients of the polynomial are real, then if the roots are complex, then they must occur in conjugate pairs. Note that if one of the coefficients is not real, that's a complex, then the roots do not occur in conjugate pairs. All right, these two ideas are very, very important. Okay, we're going to find and sketch on an Argand diagram the points which represent the roots such that z to the 6th plus 64 equals 0. Menu, calculations, define variables. So let's define a function f of z equal to z to the power of 6 plus 64. Okay, now we want to find the roots of this polynomial equation. So in another maths box, I'll go menu, calculations, algebra, polynomial tools, and this time option number 3, complex roots of a polynomial. So this is C polyroots. So C polyroots is similar to what we did before. We'll type in f of z, comma z, and we'll move out of there, and we're going to store all of them in the list ZC for the roots of the complex number. So we see that there are 6 roots there, and minus 3 minus root minus 3 minus I minus root 3 plus I. There are 6 roots, and they all occur in conjugate pairs. All right, now we're going to do even better than that, because what we're going to do here is we're going to extract the real parts. Now, remember before I showed you how we can get from a list, we can grab whatever parts we like. So if I go menu, calculations, number, and move down to option number 9, complex number tools, if I want the real part of the list, the real part of my variable ZC, then I'm going to store that one to the real part. I'll just call it REZ of that. So that's just extracted the real parts. Let's extract the imaginary parts. Menu, calculations, number, complex number tools. This time I want the imaginary part of the lists. So the imaginary part of the lists, ZC, and this time I'm going to store that one to IMZ. So that's the imaginary parts. You'll notice that the first element in this list was minus root 3 minus I, so the real part of that's minus 3. The imaginary part of that was minus 1. Now, by storing these in lists, we can actually now open up a data and statistics page, and we can add a variable here. So let's click to add the variable. This is the real axis. So on the real axis, I want to add my real parts and move across to the vertical axis, and here I'll type in, click on IMZ to have my imaginary parts. Now this is a very nice visual, because what have we seen? We can see that there are 6 roots around here. All of these roots appear on a circle of radius 4, and they're all equally spaced. And being symmetrical, you'll notice that they occur in conjugate pairs. So a very nice little visual to finish off there.